Hi and welcome back to my channel. I was asked a couple of questions about the power supply for the Grundig Transistor 5000 radio. And one of the questions was, what does it look like inside after the modifications? And the other question was, what's it like under load? Now, I don't actually have a dummy load set up, so I'll have to improvise something for that. But here basically is what it looks like. But it's not easy to see much, to be fair. But get the light in there a bit. You can see I've put the two capacitors on the board, and there's plenty of room to stand them up like that. And the regulator chip is mounted where the selenium rectifier originally went. So the selenium rectifier was screwed on this side onto that point there by my finger. And all I've done is taken a screw, and I used actually one from the transistor because it had a locking washer on it. It's the same thread, and I screwed it in from this side so that the regulator is mounted on the inside, and it's got plenty of heat sink because it's got all this to conduct the heat away. And you can see on there just about, that's a tiny piece of strip board, circuit board, which we used to call Veriboard, but I think that was a trade name. And the two tiny 10 nanofarad decoupling caps are mounted on that. So the legs are pushed through the strip board, and the caps are then connected so that both the input and output of the regulator chip are decoupled right near the pins. Now the regulator chip, the center pin, which is the common ground, is also connected to the mounting there, so I don't need to use the middle terminal to connect it because it's connected to ground that way. And then the two lines, you can see two white wires there that come off. One is the input to the regulator and one is the output. So that obviously the output to the regulator has the smaller cap across it and then goes to the positive terminal. The diodes, the silicon diodes, are down in there. I don't know if you can see that very well. It's very difficult for me actually to hold the phone with one hand and move this around with the other, but you can see the four diodes are mounted down there. And as I've taken all the switching off on the other side, that did leave plenty of pins that I could use to connect capacitors and links to. And on the main side, well, you can't see it really, but there is, I think it was a red and a blue wire or something. The center tap on the main side could be joined together, insulated with heat shrink tubing, and then tucked in between the two coils on the other side there, so it's well out of the way and it's well insulated. And then the mains connection just comes straight in the center now. It used to go through this switching, it now goes straight to one side of the fuse, and then the other sides of the fuse go to the transformer. So that's all I've done with the main side. So there's no second voltage, it's just 9 volts. The circuit I used for this, which I explained in my last video, I've used for a lot of different voltage regulator circuits on various things, and the basic system seems to work very well. Got a box full of different voltage regulators, so I can pick out the one I need for a particular application. Now the diodes and the voltage regulator are all rated at 1 amp, and this is a 400 milliamp supply, so they are sort of more than twice the rated current of this device. And there is a fuse in there, which is just here at the top here. That's a secondary fuse, and I haven't checked it, but it's probably rated at 0.5 amp or something like that. and it's a slow blow. I have got other fuses to replace if I do accidentally blow that. So yeah, there's basically I had to sort of think my way through this, and with 2020 hindsight, I would have taken photographs as I did it, so I had more to show than this. But basically, I had to work out how to get the circuit I wanted using all these pins and what was already there. So it's quite a little bit of a learning process, but got there in the end. So that's that side of it. Now what I want to do is to try this out, but I don't want to try it on the bench like this. So I'm going to stop at this point, and then there will be a second video showing it being tested under load, just a brief test under load. So bye for now, and catch you in the next video.